Okay, here in part 3, we're going to look at a couple of more, actually 3 total, nuclear reactions, and these are going to be a little different, a little odder, but the same rules are going to apply. Add up across the bottom, add up across the top. Now, it turns out that there is a form of, we'll call it matter, that is opposite of the matter that we're used to. It's called antimatter. This is not some kind of science fiction. This is not a fantasy thing. It actually exists. And one example of antimatter is the positron. A positron is the same as an electron, but with a positive charge. And you say you've never heard of that, and they don't exist in our universe very long before they are destroyed in an annihilation. If you look at the picture down here in the right-hand corner, electron-positron annihilation, if an electron meets a positron, the two of them annihilate each other. They turn themselves into energy. And so positrons don't exist for very long before they run into electrons, because electrons are all over the place. They're everywhere. So let's do sodium-22. Sodium-22, and sodium is element number 11. And it's going to undergo the positron emission. So it's going to give us an electron. We'll put a plus sign on it because remember, it's a positron. It is +1 down here, and it's 0 up there. Okay, and then what's left as we add across the bottom, this will be number 10. Element number 10 is neon. And on top, 22 on the left, 0 on the right is 22. So when we undergo positron emission, we get a neon 22 nucleus, and then the positron goes on, probably runs into another electron, and it's annihilated. All right, another kind of nuclear reaction that can occur is called electron capture, or sometimes called K capture. What that means is the nucleus reaches out and grabs an electron out of the electron cloud around the nucleus. So mercury, which is Hg, 201, and it's element number, what, 80? 80 it is. All right, it's going to undergo electron capture. It's going to grab an electron. So we're going to add, in this case, which is different than what we've been doing, an electron now, not a positron, so that's -1 and 0. All right, so when the nucleus grabs that, add up along the bottom, 80 and -1 is 79. Element number 79 is gold. And across the top, 201 and 0, 201. So you can see here, it's the alchemist's dream. We take mercury, which is common, and we make gold, with the drawback that that gold is probably radioactive. So don't run out and try to do this. All right, and so then the last thing we're going to do is a nuclear transformation. In a nuclear transformation, we are going to take a nucleus, do something to it, add another particle to it, have it undergo some change, and get new different elements. Again, an alchemist's dream. In this case, nitrogen, which is number 14, because that's given right there. Nitrogen's number 7, I looked that up. I'm going to add an alpha particle. I know an alpha particle is a helium nucleus. That's the symbol for helium nucleus. Those two are going to collide. They're going to stick together and cause changes to the nucleus of the nitrogen, and as a result, we're going to get out of that oxygen, which is element number 8. Look it up. Number 17, because it's given to us right there. And this tells us that the other thing we get is a proton. Now, you think about what a proton is. We could write a symbol like P for proton, but the nucleus of a hydrogen atom is just a proton. So the symbol for proton is, interestingly, a hydrogen nucleus. So it has a 1 on the bottom because it's 1 proton, and a 1 on the top because it has a mass number of 1. And if you go across here and add, look at this. 7 and 2 is 9, 8 and 1 is 9. 14 and 4 is 18, 17 and 1 is 18. So they add up across the top. So that's always the rule. Add up across the bottom, add up across the top.